Welcome to Ask an Expert. Hi, this is John Appleson, Marketing Manager with Pepperl+Fuchs. Today I'm joined by Tracy Molnar. Tracy works as an application engineer here at Pepperl+Fuchs. So welcome, Tracy, and thanks for being here.
Hi, John. Thanks for asking me.
Okay, the first question asks about the slope output characteristic of the MBB5 inductive analog sensor. The customer would also like to know what the linearity error value is. Tracy, can you explain both of these?
Well, first I should explain that the I3 sensor is an inductive sensor with analog output. While most inductive sensors respond with a discrete switching output when metal enters their range, an inductive analog sensor's output changes in a linear fashion as metal moves through the detection field toward and away from the sensing face. Answers to the two customer questions can be found on the sensor's datasheet. The slope of the linear analog output, which for this model goes from 0 to 20 milliamps over the sensor's 1 to 5 millimeter range, is 5 milliamps per millimeter. This is also illustrated on an output characteristic curve included in the datasheet, and the linearity error is listed on the datasheet as well.
Okay, Tracy, are inductive analog sensors capable of detecting aluminum, and is there a correction factor for this?
Yes, the specifications listed on the datasheet of inductive analog sensors are for standard steel targets, but like most inductive sensors, other metals can be detected, but there will be a reduction factor in those cases. And for an analog sensor, this means a change in both range and in the slope of the output. Reduction factor curves for 4 different metals, including aluminum, are shown on the sensor's datasheet. For an aluminum target, this sensor's linear analog output goes from 7 to 20 milliamps over a 0 to 2 millimeter range.
Okay, this customer is asking about retaining nuts for our photoelectric sensors. Tracy, do customers have to buy brand new units if just the retaining nuts are needed?
No, in most cases, we offer replacement mounting nuts. Since these should match the size and material of the original nuts, it's best if the customer contacts us with the sensor model number so we can recommend the correct replacement part.
In this next application, a customer wants to sense the start and stop of flowing water coming out of a hypodermic needle where the opening is only 110 thousandths and the stream is approximately 90 thousandths. Tracy, what can you suggest? Would one of our photoelectric sensors be suitable for this application, or would an ultrasonic sensor be better?
In this application, where the target is both very small and also clear, I would think an ultrasonic sensor is the better choice. Water is a good target for an ultrasonic sensor since it does reflect sound waves, and we offer models with relatively short ranges that could reliably detect the thin stream of water.
Okay, here's a case where a customer is trying to sense 1 millimeter diameter wire strands while they are moving at 5 inches per second. Would one of our thru-beam sensors be suitable? And if so, which model would you recommend?
A less than 1 millimeter target is too small for most standard thru-beam sensors, but we do have a thru-beam photoelectric sensor, part of our R2 series, with a special high precision feature. This adjustment allows the light spot to be made small enough to detect the less than 1 millimeter diameter wire strands in this application. In addition, the 600 microsecond response time of this sensor means the wire strands will be detected even if they move past the sensor in rapid succession.
Well, that concludes this segment of Ask an Expert. I want to thank Tracy for joining me today and thank our audience as well. For additional information, here are 5 easy ways to connect with us.